Howdy, Cal folks. It's Mr. Norman here again. We're continuing on with our transformation of parent functions. So what is a transformation? The definition reads, a transformation changes the size, shape, position, or orientation. Orientation is like direction. Which way do you go? Which way do you point? And specifically for this video, we're going to be looking at translations. That's a slide that's going to go up and down or left or right. It doesn't change its shape or orientation. So like if it's pointing up, it's always going to point up. So example for this line, if it has a positive slope, if it's pointing up before the transformation, it's also the translation. It's going to point up after the translation. So quite simply, to move, you can only move a line up and down. You cannot move it left or right. So here's the parent function. When we put -4, we see the y-intercept where it crosses the y-axis goes down 4. The same happens if we go up. So to test it out, we can go and go back to the top. We scroll down on the home page, the class stream. We can get to Desmos graphing calculator, and we can see this ourselves. We have our parent function y equals x. No. So if we want to shift up any number of units, and first again, boom, we've gone up 1. If we want to go up 5, go plus 5. If we want to go down 5, we put the same thing again. Control A, Control C, Control V because I'm lazy. It goes down 5. Notice also that while we're shifting our y-intercept, we're also shifting our x-intercept. We went to x plus 5. It shifted us to the left 5. So our left and right is going the opposite of the direction here. We have a plus 5, so our y is going up and down. But when we put this plus 5, we went to the left 5. Put this minus 5, we went to the right 5. Remember that it's going to come up in a slightly different way for the other two parent functions. So you may have noticed I skipped a parent function. We normally don't look at the constant function, but for consistency's sake, we're going to look at the transformation of this. To move it up or down, here's the parent function. We're just going to slide it. So if we look at this, it actually has a tool for us to slide. We can only go up and down, so we'll just change how much we're looking at it. And yes, y equals 0 is the x-axis. So we'll look at the first two. So just a quick note. To slide a line up or down, we're going to add or subtract. So here's our parent function. Let's color code this a little bit. Up will be green. We're already green. Up will be blue. We add. Down will be red. We subtract. So y equals x minus a number goes down. And y equals x plus a number goes up. You'll want to write this down. You'll also want to note that a constant function only goes up and down. So now we'll look at our absolute value function. So how do you think we'll go up and down? Well, let's start with our parent function. Equals absolute value of x. You type the absolute value symbol, you'll hold down shift and the backslash, and that'll give you a vertical bar. So how do you think we move it down? You're probably correct in your guess. To move it down, we'll put a plus a number on the outside. Oh, it's not a plus. Not the plus. So to shift it down, then Control A, Control C, Control V because I'm lazy. We'll do minus. Notice that the line is going in the same direction, it's still in the same shape. Just like I said earlier, the translation only moves it up and down. This will be easier to see. We turn this down to 1. Notice how close these are. Notice how these are parallel lines. They're not going to cross. They're maintaining the same shape. They're increasing at the same rate. All we did was shift it up and down. So for our absolute value functions, y equals absolute value of x. To go down, we do y equals absolute value of x minus a number. To go up, we do y equals the absolute value of x plus a number. So those shifts up or slides. This shifts or slides down. And that's for absolute value. What do you think is going to happen for parabolas? It's going to be the same thing. Of course, I'll show you. Don't worry about that. It's going to look quite similar. So we'll replace our absolute values with a square. I'm writing this in parentheses. It'll make sense later. Remember that there's an implied parenthesis around y equals x squared. I'm just making it explicit. We'll see why in a sec. So we've done it. We've slid it up, down. Oh, to do the to make your exponent, to make your exponent, to have it go up the air, you'll hold down Shift 6 and then put whatever number you need. Notice, just like with the absolute value function, the shape is the same, it's just increasing at a slightly different rate. So with the absolute value function, it was obviously parallel. So these aren't parallel because quadratics don't have a linear growth, they have a quadratic growth. So it looks like they're going to eventually overlap or cross. They're not. If we zoom in, we'll see that they're basically at the same spread as before. We keep scrolling up. It's going to look like they're obviously getting closer, but they're never going to touch. But the more you zoom in or out, the closer it looks. It looks like the lines overlapped, but they didn't. If you ever need to go back home or to reset where you're looking on your graph, press this home button and boom, it goes to the standard. So you're wondering how to make it move left and right. I know you are. I can feel it through the screen. You're also wondering, why did I use the parentheses? Well, to explain, I got to go over here. We're going to go absolute value. I'm going to go back to absolute value. So here's absolute value. Again, here's the parent function. What's this? The parent function. To move left and right, it's counterintuitive. So we're going to have left be a negative. Sorry, we're going to have left be red. So we need to be inside the bars. We need to be inside the parentheses. We need to be inside. To move to the left, we're going to add a number. Slide left. To go right, we have to subtract a number. I know I know it's counterintuitive. It's weird. It doesn't make sense. You don't believe me. I'm going to make an XY table. X, Y. And we're going to use it for the function y equals the absolute value of x minus 1. So I know a lot of you are looking at this and saying it's going to go to the left because it's a minus. We're going to start at 0. So y equals 0 minus 1. So 0 minus 1 equals negative 1. The absolute value of negative 1 is 1. So y is 1. Ooh, wait a minute. That took us to the right. So our parent function, we know it's going to be on the center like there. But x is 0, y is 1. That's in the air. That's not right. Well, okay, let's see what happens when we put in 1. So 1 minus 1 equals absolute value of 0 equals 0. Y is 0. So when we go to the right one, where y equals 0, what happens when we go 2? 2 minus 1 equals 1. Absolute value of 1 is 1. Boom. We can continue on that line, and we have just shifted to the right. It's counterintuitive, but that's the rule. You're going to need to know this. To slide to the right, you're going to subtract on the inside. To slide to the left, you're going to subtract on the inside. You think I bamboozled you? You think I did something tricky? You think I did something illegal? Well, let's go to Desmos and see what my friend has to say. Calculator's not going to lie to you, right? X minus 1. We went to the right. Surely if x minus 1 goes to the right, then x plus 1 goes to the left, and yes, it does. And for good measure, we're going to put our parent function y equals x, and boom, it's in the middle. They're parallel because the translation only moves it left to right, up and down. It doesn't change the shape, doesn't change the direction. Boom, we have these nice little lines, almost like a element symbol. And just as before, we're going to do this for the quadratic. The quadratic is going to be a little different. That's the reason why I wrote it the way I did earlier. Y equals x squared, right? Well, remember I said we're going to put some parentheses? We need the parentheses. They're imaginary parentheses. They're not imaginary. They're implied parentheses around this. We need these parentheses here so we can draw this one. Y, x. We're going to go to the left because it's red. We're going to put a 1 squared. See, we have to put it in the parentheses just like we put in the absolute value earlier. You see how it looks kind of similar? There's actually, you can think of these bars sort of like absolute value marks. We need to work on the stuff inside of here before to do the things outside of it. So now, from our rule earlier, when you make the inside, when you add to the inside, when you go positive on the inside, you're going to go left. Here, y x minus 1 squared, always in the parentheses. If we put it out of the parentheses, we're shifting up and down. Put it in the parentheses, we're shifting left and right, going to the right. So earlier on the absolute value, which one did I show you in the table? I showed you minus 1 went to the right, so I'm going to show you that plus 1 goes to the left. So x, y table, when x is 0, so y equals 0 plus 1 squared. So that is y equals 1 squared equals 1, so y equals 1. Next, we're going to go x equals 1. Y equals 1 plus 1 squared equals 2 squared equals 4. So, you see how when x equals 0, we're already at 1? Let's see what happens when we go to negative 1. Let's see where that puts us. Let's see our positioning. Y equals negative 1. So, when we put y equals negative 1 plus 1 squared. That gives us 0. 0 squared equals 0. So y equals 0. So if we put this on our graph, parent function in green, that was terrible. X equals 0, y equals 1. X equals 1. X equals 0, y equals 1. X equals 1, y equals 4. 1, 2, 3, 4. X equals negative 1, y equals 0. And look at there. We did a plus 1, and we are shifted to the left. And once again, if you don't believe me, I don't know why you wouldn't at this point, but I understand being skeptical. I appreciate it. Pay attention. Follow that Stone Cold Steve Austin philosophy. Don't trust anybody. X squared shift 6 2. There's our parent function. Control A, Control C, Control V because I'm lazy. X plus 1. Boom, we went to the left. Again, same shape, same direction, same orientation. So of course, if we shift to the left by doing a plus 1 on the inside, we're going to shift to the right by doing a minus 1 on the inside. It's exactly what we expect to see. Let's change up these colors a little bit. There we go. Hit the settings, hit the color. Let's get some nice purple in here. This is Halloween. This is Halloween. Voila. Final question. I hear you. I know the question that's on everybody's mind. If I can shift left and right, and I can shift up and down, can I shift left and up or down and right? Why, of course. Inside shifts left and right. Outside shifts up and down. Inside shifts left and right. Outside shifts up and down. Boom. What you can do with a quadratic for transformations, you can do with absolute value. So we'll hit our absolute value bars. Absolute value has a V. Value V, yes. So we're gonna shift it on the inside, shift it on the outside. This time we're gonna shift up. We can do it, we can move it, we can slide it around. All right, class, I hope this was enlightening. Make sure you write down those notes and the rules. We will catch you on the next video talking about other types of transformations that are not translations. Cal folks out. Peace.